An electric current is defined as the amount of charge per unit of time. So our charges are moving over a period of time, and this just means it's a rate. And when we think of a rate, we think about the derivative. So current I is equal to the change in charge over a change in time. Now this current will flow through a circuit. So a circuit is just a connection of multiple electric parts. And a circuit is closed when the current can flow. Can flow between the terminals of a battery. And it's open when current cannot flow. So a lot of times you'll hear people talk about open and closed circuits. Even with circuit breakers, which we'll talk about shortly, sometimes you'll talk about an open circuit breaker or a closed circuit breaker. Now, when we have circuits, we have two options. Let's draw a circuit here. You have it hooked up to some device. So for years, engineers knew about charge, but they didn't know what the charge carriers were. And so they just assumed that there were positive charge carriers. And everything was based on positive flow. So you have this direction where charges flow from the positive side of the battery around through the device and back to the negative side of the battery. And this is called conventional flow. Conventional, we'll call it current flow. And it was just always assumed positive was the correct way. And it went on for years. It was the accepted mode of looking at things. But after years of research and advances in understanding of the structure of an atom, it was found that electrons actually are the charge carriers. So the electrons flow in an opposite direction, and this is called electron current flow. Well, which one's the best? Well, it doesn't matter. Which flow you decide to use. Now, there are certain rules that apply to each. Very, very small changes between them. But everything else is the same. Um, we'll use conventional flow because that's what they use in the book. So conventional flow is chosen for the class because the book uses it. Now you might think, what's the big deal? Why do we have to have two? And you'll be surprised that there are debates that go on about this. And basically, what happened years ago, electrical engineers just decided to keep with conventional flow, even though it was known that the charge carriers were electrons. Uh, the math worked, who cared? Later, as electronics technicians started to come into the workforce, and they were looked down upon by the engineers because they were not as educated. And so the electronics technicians used the electron flow because that was the new understanding. That was the correct understanding of charge and how charges, currents flow. And so to basically combat being looked down upon, technicians basically said, hey, we're looking at it the correct way. You engineers are not looking at it the correct way. And even today, there is a controversy about who is correct, who's not correct. It doesn't really matter. Um, so if you know the rules, you can use either one. I'm going to teach conventional because that's just what the book uses, and I don't want to make a problem trying to interpret between the book and electron flow.